Welcome to Chapter 1 Foundations, Part 1. In this chapter, we'll lay the groundwork for the rest of the course. We look at what chemistry is and how it applies to our daily lives and the basic ways we describe matter and its changes. Here's our roadmap for this chapter. We'll start with chemistry in everyday life, then move into how we describe matter, including composition, pure substances versus mixtures, and states of matter. And finally, we'll examine the properties of matter and how it changes. Think of this as our foundation, the building blocks for everything else we will learn. Chemistry is part of everything we do. The food we eat, the medicines we take, the environment we live in, it all involves chemistry. This slide highlights everyday examples. Remember, chemistry is often called the central science because it connects with biology, physics, medicine, and so many other areas. As you go through this course, try to notice how often chemistry shows up in your own life. So what exactly is matter? Matter is anything that has mass and volume. We can describe it by its composition, what it's made of, and its structure, how its parts are arranged. We break matter into two categories: pure substances and mixtures. Pure substances include elements like gold or oxygen and compounds like water. Mixtures can be homogeneous like air or metal alloys, or heterogeneous like sand and water. An important point to remember is mixtures can be separated by physical means like filtration, without changing the identity of the substances. Take a look at the picture on the right. It shows you how matter can be divided into either pure substances or mixtures. If you look at our pure substance, it can either be divided into elements or compounds. Elements such as gold here is made up of only one type of atom. On the other hand, compounds are made up of two types of atoms. Here we're seeing the example of water, where two hydrogen atoms combine with one oxygen atom. Mixtures can be either homogeneous or heterogeneous. Homogeneous means two of those compounds mixed together evenly, and you can see it as one mixture. One real life example is, of course, the air we breathe is made up of multiple different gases and components, but still it looks like one mixture. A chemical example would be salt water. If you mix salt in water, you get salt water, which is a homogeneous mixture. On the other hand, heterogeneous mixtures don't mix well. You'll see them immediately crashing out of the solution. For example, putting sand in water, or in this case, the green atoms is chlorine. So if you put chlorine in water, you can see that it precipitates out, and that's why it's called a heterogeneous mixture. Matter can exist in three main states: solid, liquid, and gas. Solids have a definite shape and volume. Liquids have a definite volume but take the shape of their container. Gases have neither a definite shape nor a definite volume. They expand to fill any space. As substances are heated, their particles move faster. When matter changes from solid to liquid to gas, the atoms themselves don't change, but the arrangement does, and that can impact how a substance behaves. Let's take a look at the picture on the right. You can see that here a substance starts off as a solid, and when you heat it, you can see when the temperature increases here, this substance first starts to go under melting, and hence it becomes liquid. And when it further gets heated, it goes under vaporization, becomes gas, and then when it's cooled, it goes under condensation, goes back to being a liquid, goes to freezing, and then it can go back to its original state of being a solid. you can see how temperature plays a big role in the way the substance is arranged. It goes through these different phases of matter. So, although the blue atoms are still staying the same, its state is changing, and that can impact the way the substance eventually behaves. Properties describe how a substance looks and behaves. There's two types of properties. Physical properties like color, shape, and boiling point can be observed without changing the substance. Chemical properties like flammability or acidity describe how a substance reacts. A physical change alters appearance but not the composition. For example, melting ice or dissolving sugar. A chemical change creates a new substance, for example, rusting iron or burning wood. Take a look at the picture on your right. Here we have an example of gold. Gold, when you heat it up, becomes liquid and it takes the shape of the container. So it's changing its shape, although the identity still remains the same and its composition still remains the same. So we can describe this as a physical change. In a chemical change, a new substance is formed. In this example, we're combining zinc and sulfur to form a new substance called zinc sulfide. So in a chemical change, a new substance is always going to be formed.